Hello everyone. My name is Avinash Sawade and I'm working as security consultant at Security Board. And I do have experience of 1.5 years in web and API security. Yes. So moving further, I will discuss about exploiting
Guys,
broken access
silence,
control
please.
vulnerabilities. These vulnerabilities are quite basic but quite critical also. So yes, so today's agenda is to discuss about what exactly broken access control is, types of broken access control issues, and in that we will discuss about IDORs, mass assignment attacks, and force browsing. Later on, we will discuss about tools and techniques, tools and extensions we can leverage to exploit these vulnerabilities. So before moving forward to broken access control, we need to understand what exactly authorization is. So authorization is a general procedure which should be followed to restrict access to sensitive data and to segregate the responsibilities and roles of an admin user as well as the normal user. So authorization can be implemented in three types. First one is role-based access control. Second one is attribute-based access control, and third one is rule-based access control. So in role-based access control, we are segregating the responsibilities of an admin user and a normal user, where the applications are having multiple roles. But in case of attribute-based authorization, we do use attributes like location as well as other attributes, whether the employee is having access to particular resource or not, and in that manner we can implement that authorization checks. So this is general code snippet which which developers do implement to implement access control. It is just like a vague example. So yes, broken access control. So these vulnerabilities occurs when a proper authorization check are not implemented, and we are able to access sensitive data in unauthorized manner. So let's understand with this simple code snippet. So the code snippet is to perform a GET request to particular profile, and it is taking the parameter user ID at the endpoint. But so suppose let's understand it with the if else block. So if the user is found in the database, then directly the user will be what we can say user will be reflected in response. So yes, these are the types of broken access control. So any CRUD operation, create, read, update or delete operation performed in unauthorized manner can be categorized as broken access control. But majority of cases, these are like IDORs, privilege escalations, mass assignment attacks, and force browsing attacks. So yes, so in the reconnaissance phase, when trying to search for IDORs and privilege escalations, we need to scrape URLs. We can scrape URLs from Internet Archive. We can leverage tools like Go, webback URLs for scraping the URLs, and analyze the what type of URLs are being mapped with IDs and all. For that, we can also use tools like link finder and all to analyze the JavaScript files. We can also find JavaScript functions which are being performed. And in case of apps like React, there are minified JS files. So in such cases, we can use source mappers to unminify them and analyze the front-end request, which are like AJAX request or anything. So in the reconnaissance phase, we can also perform fuzzing. We can fuzz for API endpoints, API objects, as well as API actions. So API objects are like nothing but the data which is being held by the particular user. It can be user profile or anything. And we perform actions like create, read, update or delete on that particular object. So we can leverage word list of kite runner, that is asset node word list for API brute forcing. So the typical case scenario of IDOR. So when when an attacker is able to access the internal database objects directly via referencing the database keys, it can be termed as IDOR. So this IDOR, it is also referred to as horizontal privilege escalation. And this is the simple case scenario where in the vulnerable site, user is performing GET request to profile number 1 and he is able to get the data back. But in case an attacker changes the ID to 2, the user is directly reflected in the response. So there is no authorization check here, and an attacker can enumerate all the IDs in an application and get the data of other users. So to find IDORs, this is like generalized methodology one can follow. So identify and map all the endpoints using proxy tool or any proxy tool, and identify the endpoints which particularly deal with sensitive information, as well as so whenever you find any request which is reflecting any sensitive information, so look for IDs or UIDs, how exactly it is giving the response back, like how are we getting the sensitive information, as well as check for session management, how the token and session is being implemented, so whether it is mapped in correct manner or not. So, and in the final stage, try to modify the IDs, whatever IDs you are observing in the application, and perform the unauthorized access. But what in case of like application is using random IDs? In such cases, you can look for functionalities like invite users. Whenever in an application you do have the facility to interact with other users, you can check for those endpoints and check for the IDs being leaked in the response. As well as look for instances where username enumeration is turned on. Forgot password can be such great functionality to check for. As well as you can also include the ID parameter intentionally in the request. It is kind of mass assignment attack, but it is just to leak the user ID in the response or the particular token. We can also replace the random ID which we are seeing, which is unguessable right now, with the numeric ID. We can also refer to webpack URLs for this kind of attacks, as it may disclose the old implementation, the mapping between ID and the resource. We can also perform the entropy analysis. We can check the how exactly the token is being encoded, and try to create custom token of ours. We can use burp sequencer for also that. So in case of MongoDB, it leverages like object IDs are created in case of MongoDB database. So it is nothing but like 12-byte identifier, in which first 4 bytes are for the timestamp when exactly the object was created. It also changes second by second, as well as the second 3 bytes are for machine identifier, in which instance, like in which virtual machine it was created. Then the moving further, the 2 bytes are for process ID. So if the instance is being restarted or the MongoDB service is restarted, this process ID also changes. And the counter is like for particular object ID, the unique identifier for the data or resource. So this is sample object ID, and this is like an example for this, what exactly the parameters are there. Those are like hexadecimal encoded. We need to decode it in decimal first and then try to grab the timestamp. So to create our own object ID or to enumerate all the object IDs, we can use this tool which can predict MongoDB object IDs for us. Yes, so if you found an instance which is like vulnerable for IDOR, in such cases you can try, but you are not able to like bypass it. So to bypass the particular protection, you can try polluting the parameters depending upon the technology stack implemented by an application, the backend stack, uh, intentionally giving parameters. Like suppose there is a parameter user ID, then we will give two user ID parameters. If the application is based on Java, then it will refer to the first parameter. If the and depending upon the technology stack, it changes. Then we will look for request methods specifically for the update operations. We will try to use put methods in such cases. And we will also try to send a JSON array in the request. So if there is ID parameter, then we will enclose it within the square brackets to look if it is referring to as an array or not, and try to disclose other users' data. As well as we can also use null byte characters and evade the protection. Null byte characters like %0A, %0D. We can encode and encode it in various forms. So these are some of my findings. I have obfuscated it a lot. Sorry for that. So this was like simple IDOR on delete payment method. So there was a delete method on an API endpoint, and the internal ID parameter was being sent. So this internal ID parameter was mapped with the payment method of an user. So upon sending this parameter, I was getting just like the parameter back, or the value in the response back, but it was deleting it in the backend from the database. Other instance was like vertical privilege escalation, which I found on the same application. It was on update name parameter only. So I was able to change name of an victim with any arbitrary name which I was having control to. So I was able to control the ID parameter. So upon sending the name along with the ID parameter, I was able to get I was able to change the victim's name. So this was like response for that particular thing. And the third bypass was using privilege escalation. So particularly in this application, whatever the request I was sending was post request. There was no get request. So this was like the URL will be same only, but the parameter will be changed and the method will be changing. So there was functionality like application was having particular groups. So those groups can be deleted by admin only, but using low privilege user session, I was able to delete other groups also. So upon sending like multiple parameters, I was able to delete other groups. So this was like response for that particular attack. I was delete the groups, other groups also. So mass assignment. Moving forward to mass assignment. So it is an attack where user provided data is interpreted as an object, and it directly refers to the backend key. So in this case, developers tend to write models. Whatever the database they are creating, they refer to the models. Like for user, they will write for the MongoDB database, they will write user schema in this manner. So let's say the user ID parameter, password, and if he is admin or not, depending upon it is taking like Boolean value. And for that we will write what can we say, the routes. The routes are designed in such a way that it will directly interact with the backend schema. So this is the sample route for that, to create a new user. So in the mass assignment attack, while signing up, one can send the role parameter and the value admin for it, and disclose and able to sign up as admin. So this was like sample for the privilege escalation case. Then moving forward, we do have forced browsing. In forced browsing, attacker tries to access the resource directly by referring to object or an action. He will directly visit the URL. if direct access is not available, in such cases, he will perform like techniques like manipulating the location header, which is disclosed in the response, as well as we can also append the URL with .json extension to bypass the restrictions. Tools and extensions, I have mentioned only one tool here, which is authorize. So in authorize, we can crawl the application. We can crawl the application and look for instances of privilege escalations. So we can install it through BAP store also, BAP suite store also, as well as from the source directly. So we can configure authorize in using these all the parameters which are mentioned here. We can add like if check authenticated is on, then in such cases the application will also crawl using application will perform without authentication. It will try to perform that particular action, and we can add all the low privilege headers here, like parameters, cookies and headers here, authorization, which are responsible for authorization, and we can fetch the particular authorization header from the latest request which has been performed recently. So this is general configuration for authorize, and for the interception of the request, we can use interception filters like this, in which there are like scope items only. We will intercept only scope items, and we will not intercept other requests. As well as we can also, there are multiple filters available in authorize, but generally I use these two, scope items only, as well as response body. So suppose if the response body is containing some sort of string like admin or specific to an application, I will mention this in the content value and add that particular filter. So using this, I have added the demo of OWASP Juice Shop. So this is like the result of that particular request, where we can analyze original length and modified length depending upon the authorization and authenticated and unauthenticated requests performed. We can look for any changes and disclose if the privilege escalation has been done or not. We have to manually check all of these bypassed requests. It is not like it is successfully bypassed always in every case. So yes, that was it.
So I guess this was too quick. So no worries. Thanks Avinash. And so anybody's having questions on this thing topic?